Welcome to the third block of the course, where we are going to talk about association between variables. So far, most of the methods we have learned, they deal with one variable at a time. For example, we can investigate the distribution of sugar in apples or amount of chloride in particular river. We can calculate some statistics. We can make different kinds of tests. We can compare groups and so on. But all this time, we dealt with one variable at a time. In this block, we are going to learn how to compare several variables, how to see if there is any association between two or more variables, and how to measure this association quantitatively. In the block number 3, we will concentrate on the quantitative variables, how to find association between quantitative variables, and then in the next block, in the last block number 4, we will discuss also how to do that for the qualitative variables. So we have 3 lectures in this block, 3 learning sequences. The first is about covariance and correlation, the second is about univariate linear regression, and the third will be about multivariate regression, how to measure association between many variables. So let's start with covariance and correlation. Well, most of the time, if you measure more than one variable, you represent your data as a table or as a matrix, where every column is a variable. Every column is a variable and every row is a measurement or object or individual, right? For example, we already know very well this people data, where we have 12 variables: height, weight, hair length, shoe size, age of persons, and so on. And then we have 32 persons from different countries and of different gender. Okay. This kind of data, if you want to analyze the association between two variables, can be represented graphically in a very simple way. We actually already use this kind of plots. So the idea is following. The variables are axes of coordinate space. For example, if you have two variables like x1 and x2, in this example you can think about height and weight, you can think about swimming ability and IQ, and any other two variables, then these two variables are axes, okay? So this is how it looks like. So if you have two variables, we have x and y axis, the horizontal axis and vertical axis, and then what will be the objects in this case? Well, it's a very simple thing. Object is a point in this variable space, okay? So if you think about a particular person, for example, we know two values, height and weight of a particular person. We can use these values to find a point that is lying on the intersection of these two values, like this one, right? So we have particular x1, particular x2. So object is a point in this space. And this gives us extremely useful tool for measuring a similarity or dissimilarity between objects. For example, if 2 points are close to each other, it means these two objects have similar values for these particular variables. Of course, we can make this plot not only for two variables, and we can use this similarity measurement for many variables. But in the case of visualization, we can't make a plot with more than 3 variables. We simply cannot imagine it, right? Okay. So this is how scatter plot looks like. So once again, in the scatter plot, variables are the axes of coordinate space, and objects are points of the coordinate space. Let's look at some plots I have made for the people data. So let's start with these two. We have height and weight, and look at this. I made the scatter plot, plus I use colorization and different marker types for showing some groups. So in this case, I show the males and females. You can see that males are blue points and the females are red points, okay? So you can see a lot of interesting things. So you can see, for example, that points align on a straight line. So it means that these variables have a linear trend. We will discuss it soon. Then you can also see that you have two groups. You have females here, and then you have males here. Then you have some extreme objects or outliers. For example, this one you can see, and then these two, okay? So this plot gives you a lot of information. If you look at the beer and wine plot, the second plot, you can also see some groups. In this case, I use colors to show the region. The A means it's a Mediterranean region, and B is a Scandinavian region. Again, you can see a sort of linear trend here, not as strong as the previous one. Then you can also see some groups. For example, you can see that these all are people from Mediterranean region, and these people are from the Scandinavian region. Okay, so these plots are very, very useful. But in this particular lecture, we will be interested only on one thing. Do we have any trends in this plot? Do we have any linear trends in these plots or not? Okay. Let's look at the several combinations for the people data. So that's the first plot. We already discussed it, right? So we have a clear linear trend. So it means that if person is tall, this person is heavy and vice versa. This is quite natural, right? Because if person is tall, it means that the person has a bigger body, and therefore the body will weight more, okay? And this trend is quite clear, right? So we can clearly see that we have almost a straight line that fits all these points. Now, the beer and wine. Again, we have a linear trend here as well, but the points are more scattered around this imaginary line. That's one thing. The second thing is the direction of the trend. You can see that the direction of the trend is opposite, because if person drinks more beer, this person drinks less wine, and vice versa. So later, we will learn that this kind of trend is called a negative trend, while the trend that we can see for height and weight is a positive trend. Okay. Now let's look at another interesting trend. It's a trend between age and income. Okay. Apparently, age and income should be associated, right? Because, I mean, the older you become, the more experience you have, and therefore the salary should be a bit larger. Okay. And then you can see that indeed we have a very clear trend here. Maybe not as clear as for height and weight, but still points align around a straight line. Okay. Then the final, it's age and wine, and in this case we don't see any trends. We can't make a line that will fit these points well. Okay, so in all these cases I can make these imaginary lines in most of these cases, and now you can see that points are more or less scattered around this imaginary line, right? So you can see that, for example, for height and weight, the points are almost exactly on the straight line, and then for income and age a little bit more scattered, and for beer and wine even more scattered. Plus, for beer and wine the line has negative slope. Okay, let's learn how to measure this linear trend, how to measure how strong the linear trend is quantitatively. So meaning how to calculate a statistic that will tell us how strong the trend is.